Page 46, question 61, part C. Now, we've done part A and part B, so we're up to a harder part here. Assuming the standard deviation stays at 6.7 grams, what should the company set the mean to be if it wants only 2% of weights to be below 750? So we'll start with our curve. We're going to need quite a bit of space for this one. What should the company set the mean to be? So we're going to have a new mean. Standard deviation stays the same. The company wants only 2% of weights to be below 750. So if you remember from the mean, this line here, back down below the curve, is 50% or half. The total area under the curve is 1 or 100%. So the area from this line, the mean line back, is 50% or 0.5. So 2% of weights to be below 750. The 750 is going to be right down here somewhere. So that the probability of having a weight below that, which is the same as the area under the curve below that, we want that to be only 0.02. And we need a mean that's going to give us that. It sounds a bit like an inverse problem, so we'll write inverse here. So we're over to the calculator, menu 2, we want distribution, normal, inverse. Now it's definitely a left tail, 2%, standard deviation of 6.7, but the problem is we now don't have a mean because the question wants us to have a new mean and we don't know the mean. So when we get to this stage we have a problem. What we need to do is to find a curve where we do know the mean and the standard deviation. And that would be the standard normal curve that has a mean of 0 and a standard deviation of 1. That's the basic normal distribution curve. We call it the standard, and we usually use Z. The standard normal distribution curve that all other curves are as a result of. If we copy this area here of 0.02, now what we'll do is we'll find the value on the Z curve that corresponds to an area of 0.02. So back over to the calculator, left tail 0.02, standard deviation of 1, mean of 0. Let's find what the value is along the bottom. So this number here, this value, is negative 2.054. We'll keep a few decimal places there. So that means that 750 on our weights curve corresponds to a value of negative 2.054 on the standard curve. Now to get from here to here we've used a formula, or the calculator uses a formula. It's a formula on the formula sheet, and it looks like x minus the mean divided by the standard deviation equals the value on the Z curve. So the calculator's taken 750, it's subtracted this mean here that we don't know, divided by the standard deviation up here, and it's ended up with this value of negative 2.054. So if we put in everything we just said, the value is 750 minus the mean that we don't know, divided by the standard deviation of 6.7, that's what the calculator's done, to get a value on the Z curve of negative 2.054. Now at this stage and in this course we can just use solver, put all of this into the calculator and solve it to find what the new mean should be. So over to the calculator, we need to go to equation, and we want to solve. Now we need to put in the equation, and I think we're going to need to have brackets around the top line, so we'll go bracket 750 minus, we'll use x to stand for the mean, divided by the standard deviation, and that gave us a value of negative 2.054. 4. And remember, with solver, it's really important that you push solve. So there we go. Calculator's told us that the mean must have been 763.8 grams to 1 dp. And we'll just go back and check the diagram. That if that's 750, then that certainly looks like it should be 763.8. And you could check that by going through the whole problem again using a mean of 763.8 and just check that the probability of having a value below 750 is in fact 0.02.